Some days you want to do repair work, and some days you just want to space chat about the Arduino IDE. And SpaceDog is here because he loves IDEs almost as much as I do. Oh, maybe not. IDE stands for Integrated Development Environment. It's software for building applications that comes with lots of developer tools. The Arduino IDE is required to create projects with the Arduino. It's easy to download and install from their website. The programming language used for Arduino is a variant of the C++ language. In this environment, programs are called sketches. Both capitalization and punctuation are important. A mistake in either of these things will create a compiler error. Certain text like function names or input parameters change colors when entered correctly, which is a helpful feature of the IDE to know if you've missed something. Let's talk about some common functions and features that you'll use within the Arduino IDE, starting with two functions that are required for every Arduino sketch: void setup and void loop. Void setup is the first function that will be executed in a sketch and will only execute once. It typically serves to set pin modes to either input or output or initialize the serial monitor. It can also contain other functions, but the basic thing to remember is that it only runs once after each power-up or reset of the Arduino. Void loop is a function that operates repeatedly as long as the Arduino has a power source plugged into it. This lets the program actively control the Arduino board and components. Both or either of these functions can be empty, but without including both of them, the program won't compile. Curly brackets identify the beginning and end of functions or statements. They're used for both void loop and void setup, but can also be used within these functions for things like if statements or custom functions. Not including both the opening and closing brackets will create a compiler error when you try to upload the code, but the IDE will alert you that that's the problem and where it needs to be fixed. Semicolons have to be included at the end of every statement or to separate elements within a loop. This will also create a compiler error if it's missed. Comments are created by two forward slashes. Anything written after them does not get used by the program. These are just useful comments for humans. The serial monitor is a tool within the IDE that can print out text from your program. It can be used for debugging, testing, or communicating with the Arduino board. It can be opened by either going to Tools, Serial Monitor, or Control-Shift-M. The serial plotter functions similarly to the serial monitor, but instead of printing text data, it works as a graphical tool. It can be opened by going to Tools, Serial Plotter, or Control-Shift-L. Pin mode takes two arguments that are exactly what it sounds like, the pin you're referencing and the mode. The pin can be any pin on the Arduino. You can use either the numerical value of the pin or the variable name that you use for that pin number. The mode is either input or output. Use input when the reference pin is providing input to the program, like when you press the push button. The press of a button indicates to the Arduino that something needs to happen, so this is an input. Use output when the pin is causing something to happen, like turning on an LED. You don't turn on an LED by poking at it, you turn it on by writing something to it. Digital write writes either 5V or 0V to a digital pin using either high or low. If you write high to an LED, you'll be turning the LED on. Analog write is similar, but instead of only writing high or low, it can write a range of values to an analog pin. Digital read and analog read do the opposite. They read in the state of a digital or analog pin. Digital read might read in the state of a push button. Is it pressed or not? Analog read might read the state of a light sensor. Light sensors detect the illuminance of light, not whether there is or isn't light, so that would be an analog value. Delay delays the next statement by the amount of milliseconds specified in the parentheses. This can be useful for things like printing to the serial monitor so that the text prints slow enough to be readable. Serial.begin initializes the serial monitor and sets the baud rate per second. 9600 is the default and most commonly used baud rate, but it can be set to other rates as well. Serial.print prints out whatever you put in the parentheses to the serial monitor. It can print either a string, which should be put in quotation marks, or variable information. Serial.println does the same, the difference being it starts the next statement on the next line instead of smushing it all together. Variables have to be declared with a data type, like Boolean for true or false, int for integers, or float for decimal values. Not declaring the data type will create a compiler error. It's common to use const.int to declare the pin for a variable, such as const.int LED pin equals 13. The const keyword is for constant, and it tells the compiler not to let that variable be changed. These are just some basic fundamentals to help you understand how to get started programming with the Arduino. For beginner tutorials where you can put this into practice, check out my channel for projects where we can repair our stolen spaceships together. which I need to get back to doing before any aliens make fun of me for my broken ship.